In today's lesson, we are going to talk about properties of the organic compounds and isomers. Before we get started, please make sure to download the handout from Google Classroom and please make sure to take notes on your packet. Properties of organic compounds. Compared to hydrocarbons, organic compounds with functional groups have higher melting and boiling point temperature due to the hydrogen bonds. All the functional groups have an electronegative atom, such as oxygen or nitrogen. If you have an oxygen or nitrogen in a compound along with hydrogen, then there will be a hydrogen bond. There will be an attraction between hydrogen and the electronegative atom. And due to those hydrogen bonds, there will be additional attractions in between molecules, which is known as intermolecular forces. And because of that intermolecular force known as hydrogen bond, the melting point or the boiling point for that compound is going to be higher than usual. So functional groups have hydrogen bonds compared to hydrocarbons. They do not have hydrogen bonds, and therefore functional groups have higher melting and boiling point than regular hydrocarbons. Hydrocarbons are usually nonpolar. And if hydrocarbons are nonpolar, that means hydrocarbons are insoluble in water. Remember the concept of like dissolves like. Since water is a polar molecule, hydrocarbons are going to be insoluble in water, which also means that functional groups are going to be most probably soluble in water. We also need to know that most organic compounds are non-electrolytes. Let's move on to isomers. Molecules with identical chemical formula, such as molecular or empirical formula, but different arrangement of atom with different properties are called isomers. For example, if you look at butane, you have 4 carbon and 10 hydrogens. If you look at isobutane, you still have 4 carbon and 10 hydrogen, but the molecules are arranged in a different order, and therefore they're known as isomers. When you think about isomer, think about Legos. The more Lego bricks you're going to have, the more structures you're going to build. For example, if you look at isomers of C6H12, we have so many of them. I can even draw more than what I have in this slide. 2-methyl pentane, pent 1-ene, 4-methyl pent 1-ene, all of these are isomers, meaning all of these structures have 6 carbons and 12 hydrogens. However, their properties are different because their arrangement between atoms are different. If molecules have same chemical formula but different arrangements, then they're going to have different properties. And they're going to be known as isomers of each other. So isomers are basically very simple and straightforward. The more carbons you're going to have, the more isomers you're going to get for an organic compound. Let's take a look at this Regents exam question. They gave us a compound and they want us to figure out the isomer of this compound. The first thing I would do is I would count the number of carbons that I have and hydrogens that I have in this compound. So I have 4 carbon and 3, 6, 7, 8, 9, 10. 10 hydrogens. So if I'm looking for an isomer, I also need to have 4 carbon and 10 hydrogen in that compound. If you notice the compound, it doesn't have any double bond in it. So it's a butane. So I'm looking for an isomer of a butane. Right away I notice a double bond in option A and a triple bond in option C. There is no way we can have an isomer of a butane that has a double or triple bond. So I should cross out these two options. If you look at option D, in this option, I have a CH3 group, then I have a carbon with 1 hydrogen, and then on the other side I have another CH3 group, and then on top of it I have another CH3 group. It seems like 1 carbon, which is in the middle, surrounded by 3 groups of methyl group and 1 hydrogen. If you notice this carbon, it is exactly the same that what we have over here. 3 groups of methyl group, right? Surrounded by this carbon, the blue carbon, is surrounded by 3 groups of methyl group and a hydrogen. So option D looks like an isomer, but it is not. It is the same exact structure that is given initially in the question. So please be very careful. When you're looking for an isomer, the arrangement of the molecules must be different. If you look at option B, we have 4 carbons, and then we have 10 hydrogens, and the arrangement are different compared to what we have initially. So for option B, this is an isomer of the given compound. Again, for isomers, the arrangement must be different. Here, all of those carbons are attached in a single straight line. Here, the carbons are not attached in a single straight line. However, both of them have 4 carbons and 10 hydrogens. So clearly, they have same molecular formula, but different arrangement of atoms, and that's our isomer. If you look at the questions regarding isomers based on Regents exam, for the first question, we have to find an isomer of C2H5OC2H5. The first thing usually I do is I count the number of atoms in the compound. So I have 4 carbons, I have 10 hydrogen, and I have 1 oxygen. So I'm looking for same number of carbon, same number of hydrogen, same number of oxygen, but with a different arrangement. In my first option, I do not have 4 carbons, so right away I can cross it out. In option C, I have 3, 4, 5 carbons. I only need 4, so I can cross it out. Option B, I have 2 oxygen. Obviously, I need only 1, so I can cross this one out as well. So the only option that makes sense is option D, where I still have 4 carbon, 10 hydrogen, 9 of them are here, 1 of them is right there, and oxygen in the middle. So the structure or the arrangement of the atoms are different than the initial one. And therefore, these two are isomers of each other. If you look at the question, the next one. So for the next question, if you have an alcohol and ether, and they have the same molecular formula, which is C2H6O, first of all, they're already telling you you have alcohol and ether, which is 2 different functional groups. So it could be option C or D. If you have 2 different functional groups, their physical and chemical properties cannot be the same. Meaning, if you have different functional groups, the physical and chemical property must be different. And therefore, option D is our best possible answer. So two functional groups can have the same molecular and empirical formula, but they can still be isomers of each other. This question, which compounds are isomers of each other? And that's a slightly difficult question because you need to know how to draw them properly, or at least you need to know the functional groups to answer this question. For this question, I would highly recommend you to draw each and every single option, and then count the number of carbon, hydrogen, and or any other atoms that exist in that compound to figure it out if it's an isomer of each other. For methanol and methanol, the chemical formulas are different. And again, please review how to draw organic compounds. The easiest way to answer this question is by using process of elimination. If you're looking at option B, we have two different functional groups. We have the same functional group, but we have different prefixes. So right away, I know that that's not our best option. Because pent means 5 carbon, prop means 3 carbon, and both of them are organic acids, so their functional group are exactly the same. If they have different number of carbons, they cannot be isomers. For option C, they are the same exact functional group, alcohol. They have the same prefix, which is prop, meaning 3 carbon. However, the functional group, the location for functional group is different. So the arrangement of the functional group is different, but they have the same number of carbons and hydrogens, and therefore option C should be our best possible answer. If you look at the last one, you have chloro means chlorine, you have bromo means bromine. So that's two different elements. You cannot have isomers with two different atoms, and therefore that is also not a good option. The only tricky one is option A, and again, for option A, it's better if you know how to draw these compounds, and therefore you can select option C for your best possible answer. This is it for isomers. In our next video, we're going to talk about organic reactions.